Hi, I'm Bob. Welcome back to 5-Minute Econometrics, a program focusing on fundamental econometric concepts and estimation methods. Today, we will explore the inconsistency in the OLS estimator. In the context of a large sample, we can derive the inconsistency or asymptotic bias of the OLS estimate when the zero correlation assumption is not satisfied. From the previous topic, we know that the probability limit of the OLS estimator beta hat equals the population parameter beta plus the ratio of the covariance between x and epsilon to the variance of x, where x is the explanatory variable and epsilon is the error term. This ratio is called the inconsistency in beta hat, or the asymptotic bias of the beta hat. It means if the error term is correlated with any of the explanatory variables, then the probability limit of the OLS estimate will not converge to the true value as the sample size approaches infinity. One source of inconsistency or asymptotic bias is omitted variables. Suppose the true relationship between x and y is as follows. The true model has two groups of explanatory variables, x1 and x2. However, we only collect data on x1 and regress y on x1 only. Thus, the error term mu in our regression model equals x2 times beta 2 plus epsilon. We write down the OLS estimate for the coefficient of x1 in matrix form and replace y with the true relationship. Beta 1 hat contains three terms. The first term is the true value, beta 1. Let's focus on the second term. Part of it is the OLS estimator from regressing x2 on x1, gamma hat. Finally, we take the probability limit of beta 1 hat. The last term becomes 0 because we assume that the error term in the true model is not correlated with any of the explanatory variables. Gamma hat converges to the true value gamma as the sample size increases. Therefore, we obtain the formula for the inconsistency or asymptotic bias in the context of omitted variables. The direction of inconsistency in beta 1 hat depends on beta 2 and gamma. If x1 and x2 are uncorrelated, then gamma equals 0, and beta 1 hat is a consistent estimator of beta 1. If x1 and x2 are positively correlated, and x2 has a positive partial effect on y, then inconsistency in beta 1 hat is positive. That is to say, the OLS estimator beta 1 hat is upward biased. You can check other cases and find the direction of the inconsistency or asymptotic bias. Today, we have derived the inconsistency or asymptotic bias when the zero correlation assumption is not met. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.